Well, hello everyone. My name is Mike. I'm with Data Nexus. Today I'll be hosting the Builders Office Hours, episode number 24 for the Graph BuildersDAO. Just as a note, this will be recorded and posted on YouTube, so keep that in mind. Firstly, I wanted to give a little blurb on what the BuildersDAO is. We're a network of developers who build subgraphs or substreams. In short, the BuildersDAO is a hub where new or existing protocols can come to request a subgraph or substream to be built. A bounty for that project can be put up, and a developer can apply to build it, and then once it's done, can receive a bounty when it's complete. We're always looking for more skilled developers to join the DAO, and at the end, I'll post up a link for our website where one can apply to join the DAO. And also, if there is something to get built, if you're a protocol, you can reach out to Thomas or myself, and we'll be glad to get you started on the process. So today, we have a BuildersDAO developer, Thomas. He's going to go into depth on a project he just completed regarding Substream Composability. We recently posted a video on YouTube, and feel free to check that out after this. I highly recommend it. It got a lot of love. Myself, coming from like zero substream development knowledge, it made building a substream or a subgraph powered, a substream powered subgraph development process seem very doable. So without further ado, I'll kick it off to Thomas, and he'll take it away.
All right, great. How's everybody doing today? Like Mike said, he did a great introduction. I'm from the BuildersDAO. I pretty much have a role of product procurement, so we go out and try to get other protocols and really whoever needs some type of subgraph or substream development. I try and go out and pull them in to the ecosystem. Not only do we look for people who are looking for subgraph substream development, we're also out there trying to network and get in touch with people who maybe going to another provider, trying to convince them, bring them back into the ecosystem. Our main goal at the BuildersDAO, underneath it all, is to boost the ecosystem itself of the graph. So we've got a lot of fun things going on for this year. I'm really excited for that. Recently, we started dipping our toes into the education side of things. So one thing, I don't really have big experience with subgraph development prior to coming in. I just had a really good passion on with substreams. I'm not a Rust developer by any means, but the more and more I work with it, the more and more I'm starting to love it. So one of the big features with substreams is the composability of them, and it's usually portrayed in a way like they compare it to like building with Lego blocks, right? So one developer could go out and build a substream, and rather than you having to like pull down that code and implement it into your substream, you could just import it into this upstream. And you have all these little Lego blocks where you could just, start with the Uniswap V2 version of it, import that, and then kind of build onto that. And then you deploy your substream, and then someone could then pull that and start building on top of it. So it's one of the big things that excites me with substreams itself. And for our demo, we decided to use our Chainlink price substream. It's one of the first substreams we ever built. So pricing is a big thing when you're dealing with indexation on the chain. Everybody wants to go get a price, and why would you want to go out and have to develop your own Oracle or pricing model in your substream when you could just import ours, right? So that's the intention. I'll share my screen just to get us going here. So, let's see. Are we good? Everybody can see it?
Yeah, looks good.
All right, great. All right, so the Streaming Fast team recently built a registry, and I do demo this in my video. It's a place you could go after you've you built your substream, you could upload it here, and it will help others search for something that may have been already built, or you could just see a little bit more details about the substreams in a graphical way. So let's say I'm a new developer. Okay, I'd like to pull in some type of pricing into my substream I'm building. You could come here, just search price or whatever it is, and we get two results, right? So we have a Messari one, and we have ours Chainlink one. Now, this one is a little outdated. We have to push up the new one. The new one is on our subgraph. On our GitHub. So I'm going to be using that one for today's demo. But this is a good place for you to go and just start researching other work that's been put out there. If we look at the Messari one, this one has a little bit of Chainlink stuff. I believe they just go to Chainlink to get the Ethereum USD price, and then they actually store the Uniswap price. So if I wanted to get Uniswap prices into my substream, I could easily import this one as well. For today's demo, we'll just use the Chainlink one. So if we click the Chainlink one, you could see all the modules that were built in that substream for use. And I'm going to show you another way of finding out some more information about the substream. But, you could say, oh, great, okay, this looks like something I could work with. So we'll go right into the substream code. I'm going to be a little bit more detailed in this demo. And if you guys have any questions, feel free to just stop along the way. So one thing I love about the Substream CLI is this init command. It will just build the substream for you from scratch. All you need is a contract address, right? So we're going to use the Lido contract address and get the contract address. So if I do substreams init, it's going to ask me the project name. So I'll just do, demo, Lido. It's going to ask me the protocol. So Ethereum protocol, we're on mainnet. And then it's going to ask me the contract addresses. Now, just to note, I did make a PR to this where it will allow you to load in ABIs that aren't on a block, aren't published on Explorer. So some situations you may be dealing with sensitive contracts that people don't want their contract published. I've made a way to do that. I don't know if the team actually looked at it yet, but it's there and available if you ever run into that use case. So we'll put the address in, and you could put multiple addresses. So if you wanted to just get all the events from like 5 different contracts, just plug them in here, which is great. We're not going to use another address, so we'll leave it empty. Tracking one contract, so we'll just do Lido contract as the name for the Lido. Let's just do Lido. All right, so now what it's doing, it's going to the Explorer. It's going to pull down the ABI, and it's also going to pull down the creation block so it knows when to start the substream from. So now it's generating all the events from the ABI. On that, I just actually built the latest version of the CLI, so that's a new question. I'm not too sure what that is. All right, so as you can see now, we now have a working project directory, and it's generated the full substream for you, and it even has schemas for a substream powered subgraph right away. So now if I just wanted to push this up and start indexing on with a subgraph, it's already here for me. I really don't even have to do anything else. One thing you always have to do is change it to your current working version of Cargo. I think mine is, let's see, 1.71.1. That way you can build and run on your local machine. See if there's any. Just running my analyzer here to see if there's any problems. I think last time I did this, there was a problem with like numbered contracts. It doesn't label them correctly. I have to get that over to them. Streaming Fast team to maybe fix that, but it's a quick fix. So while that's building, we could go through the manifest of the substream. This is your typical one. So you can see this import section. This is what we're going to be using to import other substreams. So just keep that in mind. And then you have your module section, right? So we have a map events, which is going to map all the events. It's a map module. That module is imported into a DB out. So if you wanted to write to a database, such as Postgres, you can. And then also we have a graph out, which pulls those map events in, and then it emits the entity changes to the subgraph. All right, so it looks like everything's good. We could test this real quick by doing substreams build. Actually, could I do make build? Okay, I'll just do substreams. Let me see what is. Take this. That's why. So now it's built it up. Shouldn't be any errors. So what I'm going to do now is just test that the events are emitting from that map module, and then from there we'll go into actually pulling in a separate substream. All right, great. So I'll finish with build them with no errors, and now we could do substreams. Let's do GUI. The GUI will create like a little graphical interface in your terminal to show you like all the modules that are being executed and what's coming out of them. Substreams YAML, and we're gonna do I believe it's called map events. Yeah, we're gonna run this module just to see what's coming out of this. All right, so come over here, you could see like up here in the graphical explorer, you have these little dots. So these are the dots that you could navigate through, and those are the ones that actually emitted something. So you could see all these things down here. So on this block, we should have something coming out, right? So Lido submitted, and this is going to be an array of all of the submitted events that are being emitted from the contract. So like I said, using the init command as like your base gets you like 90% of the way there. Obviously, there's probably going to be a lot more data manipulation, but at least you get all the events in a nice, clean fashion to work through. So we'll be using this one. This is when anyone, I believe, deposits Ether into the staked Ether contract. And what we'll do is we'll take this amount, so we know how much Ether they staked. We'll go get the ETH pricing in USD. We'll do some multiplication, and then we'll return a US dollar amount with this event. And then obviously at the end, you'd be able to use that entity for whatever you want. So I'll stop that now. And first thing we're going to need to do is make a protobuf definition for the new entity we want to create. So it's going to be very similar to the submitted one. So I'll just take this Lido submitted, and I'll make it submitted USD. So just for the interest of non-complexity and time, I'll take out some of these things because we don't care about them. But good thing is that the transaction hash of that event, the index of that event, the block time of that event, and the block number of that event is automatically generated with that init command. So again, really, really cool stuff with the init stuff. Do string, and we'll do the US amount. One, two, three. All right. So now we have how base. This is something that would be then transmitted up. It's going to be mapped out in the substream, and then you would be able to turn this into an actual entity in your subgraph. Okay. So we'll go with this. We have the amount of ETH, and then we'll have the USD amount. Or we'll put like value. All right, great. So now we have to see if this works out. All right. So now we're just generating that in the code. We'll have that available to us. And here there should be a submitted USD. So now we have the Rust equivalent of that protobuf to work with. All right. We see the value here, USD value. All right. So now let's jump into the actual importing of the Chainlink substream. So we have the map events module that we were working with, and we want to take that and import it. So we're going to make a new maps. We'll do and it's going to take a import of the events. So we could do the type, and it's going to output US. Just put submitted USD. All right, so now we have the events coming in, and we're going to do 4 submitted events in Lido events dot submitted Lido submitteds. Here we go. So now we're looping over that array that we seen in the CLI to get all of those lighted submitted events at every time that they were emitted from a block. And then in here, what we're going to want to do is let's make a placeholder variable like USD price. And in this spot, we will we'll get the price from the Chainlink substream. So right now it's just a placeholder, but we'll just leave that as is. And then from here, you would do something like a output. So let's see. be like submitted sender. We'll do else amount. And USD value. It's gonna be a string. So again, we're not gonna have the dollar value right now, but it would return the submitted entity. Now, I'm not really doing this the right way. I should be like pushing this to an array and then returning all the submitted events. But we'll just leave it as is for right now. All right, I'll handle that in a second. All right, so like I said, we are gonna go and pull the substreams from our GitHub because we have a older version on the Explorer there. So where do we got it here? I think it's in just substreams. So in the substreams repo that we have, these are all the substreams that we kind of showcase. And we have releases for each of them, which is going to give you a SPKG file. Okay, this is the one that you're going to want to import into your substream. So if we go into the code itself, we're going to see that it has a store. So that's primarily what we're going to be working with today. We're going to go into the store and get the stored value of ETH, because every time something is emitted from the Chainlink pricing, we go to the store, we save that USD price, and then you'll be able to access the actual store. So we have this Chainlink price store here, and we could see we should do like better documentation. I don't want to throw us under the bus, but it should be there for you to use right off the bat of like, you know, how could I actually use the store itself without having to go into the code and research this. But we can see that we're setting the price by address. Okay, so the key in the store, the store is a key value pair. So the key is the price by address, and then address 1 and address 2 for the pair. We also have price by aggregator, so you could look up with the key of price by aggregator, and if you know the aggregator address, so you could just get the price directly from there. And then you have price by symbol, which is the most easiest one to work with. Just another note, the price by address only works on mainnet because they have the Chainlink registry is only deployed on mainnet. It's not deployed on other networks, so you won't even be able to get these events. So price by symbol. For today's demo, it's pretty simple. We know that we want to ETH USD price, so we're just going to type in ETH USD to get the price. So here's where you would be accessing. You need to know the key to use the store. So if you do use other substreams, documentation purposes, it should be there for you. Just by, you know, like it should be habit for anyone pushing this stuff up to give you that documentation. Otherwise, you would have to go into that store module and see how it's actually being set. So we know we're going to use the price by symbol here. So that is the way we're going to access it. Now we're going to take the SPKG file here. Go up one, click this. We have our SPKG. We could just use this directly. Copy the link address, and we're going to pull it Chainlink prices on our import. All right. So Chainlink prices, and boom. That's really all it takes to get someone else's substream into your substream. Obviously, we're going to have to plug in some variables in places, but at this point, your work is pretty much done. Right? I'm going a little bit more detail. It's just Substream development as a whole, but at the base, you're done. You already imported the Substream. Now, in my YouTube demo at the time, there was no way to do this. So each Substream has a initial starting block, and for our Chainlink Substream, the initial starting block is before this initial block of this contract. So in some cases, you're gonna need to switch the initial block, because you need to build the store up. Let's say you're doing some data aggregation in the store, like cumulative USD over time in that store. You would have to kind of morph your Substream into using that initial start block. But for our use case today, we want to start it from here. So there's a way to override that in the manifest directly before the latest release, which was very recent. You would have to make a separate YAML file, a separate manifest, and then pack it, and then re-import the SPKG. But thankfully, they've come up with a better solution for that. So I'm going to just copy and paste this because I have it from a different area, but we'll walk through it. So you could have this networks array here, and it will allow you to specify per network a specific configuration. So that's exactly what we're going to do here. We have the Chainlink prices, which we imported, and then each of the modules, we're going to override their initial blocks. So we know the initial block on this is going to be same. So we're going to start here, start here, start here, start here. Now, again, I'm just doing this for demo purposes, but the right way you should be doing this, and it's keeping in mind, is that what's going to happen is we're going to start the Chainlink prices at this start block. And if an event that didn't transmit the price of ETH USD was available in this start block, it's not going to be there from the first event. So you may want to just push it a little bit sooner. That way you could get those prices in the store. And then going forward, it'll be fine. But if you want the price for the first emission of that submitted in the Lido contract, you're going to have to play around with it. There's no good way other than maybe running the Chainlink price store separately and seeing oh, okay, in this block, this is the closest block that a ETH USD value was emitted from the Chainlink prices. But again, just for today's demo, the first couple submitted events probably not going to have that available to us. So when you now want to import the chain,
Thomas, just real quick, Eric asked a question in the chat. Does network section also allow you to override the contract address since these differ per chain?
So you could use a there's also parameters, which we're not going to go into today. But when you build out a Substream, you could import a parameter string into each module. And that's so the question, if the Substream is based and supports parameters, which it should, a Substream developer should keep that in mind when developing. I tell that to everybody I speak to, you always should try and use parameters. So yes, you would be able to say, for the chain of mainnet, here's my initial block, and then I think you could, it's something like parameters, something like that. I'd have to check, and then you would do the same thing. For this module, I want to use a parameter of 0x00000, and that would override per chain. So it's dependent on the Substream developer to do that, but it's possible, right? If they just hard-coded a constant variable in, it's not going to help you, because you would actually have to pull down that Substream's code and then replace that value. But if you want to override the parameter, you can from here, which is the standard way of doing things in Substreams. You should be using parameters when you build out your Substream. So that's where you would do it. Great question, Derek. Great question. So now that I should really pull up the chat here. We do this. Hold on. There we go. There we go. All right, great. All right, cool. So, Mike, we're good with any. If you see any other questions while I'm just going through this, let me know. All right, just interrupt.
Absolutely, I'll chime in as necessary.
All right, cool. So, all right, so now we overrode the initial blocks, and now we have our manifest set up. But the next part of this that we need to do is import the imported Chainlink price module, Chainlink price store, into our new module that we built. So, and here we have the map USD. So we're gonna come back to our manifest. We're gonna put right here. We're gonna put modules. We'll make a new one. Name. It's kind is a map module. The initial block. We'll just take this. The inputs. Now the inputs are going to be the map events, right? So we have an input of map. And we also want to import a store, right? And we're going to do the Chainlink price store. And the output is going to be that protobuf definition that we made. So type. And it's submitted. Visty. So now this is telling the manifest that we have a new module. We have inputs on this module of map events, and we also have a store that's being imported, Chainlink price store. Now, when you go into the module itself, you need to know the type of store it is to actually import it properly into your module. So one thing that's missing from the registry is like what type of module it is. But you could get that by doing a Substream's info. So if I pull this up, because it's probably going to output a little bit more, then it's on the screen. So if you do the Substream's info command to the substream that we're importing, you're going to be able to see more detailed information about this. So you could see here's all the substreams, right? We have the name, the version. Here's the module, store confirm feed, get Chainlink answers, and Chainlink price store. So this is the store that we want. Now you can see the value type here of of big decimal. So we know that there's a decimal value in that store in the key value pair. So we have to specify that, yeah, we're using a store, but we want to use a store of type big decimal. That way, when we access the value, it's automatically going to infer the type for us. So this part is, I haven't seen this anywhere else in the registry or anywhere else. So this is an important step of actually identifying that. So if we come back into here, we know we have the events, and let's say we want Chainlink price. And we're going to do a store get. So up here, where do we have it? One sec. Just want to get this right. I just look up my composability one. All right, so we can see in the composability demo that I did for the YouTube video, we have this import of Substream store and store get big decimal. So those are the ones that we're going to want to use to import here. So now we have those types available to us to do on the import. So we're going to use the store get big decimal, and here we have a type of store get big decimal. Now, that allows us to now access the store directly from that imported substream. So like in this area here, we're going to replace this. Let me just, so I'm in sync with the one we did. We have this value here. We'll do it up here like I did in the demo. So I'll walk you through exactly what's going on here. So this is the ETH price, right? So we have the import of ETH price. This is from the substreams that we're importing from. And then we have this get last. Now, I just want to note that when you access the store, there's 3 ways of accessing it. There's get first, get last, and then get at. So when you store the price, when you store any value in the store in substreams, there's this concept of it's not really a concept, it's just a known thing of ordinals, right? So let's say the value of ETH changed 3 times in a block. Each event would have an ordinal of chronological order of the event firing off. So if you want to be really, really precise, you could say at a given ordinal, what was the price, right? So I know that, an event fired off at ordinal 10, 20, and 30. Now I want to access the price at in between 20 and 30. You could pass in it's sick, right? For our use case in this, we weren't as precise of the price firing off 1, 2, 3, 4 times. So we just stored it at an ordinal of 0 always. But you could actually access in between the 20 and 30. Okay, I have one at 20. I know that this event fired off, the events that I'm looping through, the submitted, fired off at 35. I want to get it at that latest time of the 35th ordinal. And then you have that very, very, very specific way of accessing the store. You could also just do get last. So get last will be at the event of the block, what was the price? And then you could also do, I believe it's get first. Is it going to help me out here? No, it's not helping me. Yeah, we'll just leave it at get last for now. But get first would get you the value at the start of the block. So there's multiple ways of accessing the store. And our use case today, so if you have 2 more events in the same block to get emitted, you need something to be careful. Yes, exactly. That's what the ordinals do. So when you set the key in the store, you set the ordinal value, which is in the block entity. And then when you go and access it, let's say you're accessing it over a different set of events, you could pull the ordinal of that event and then go get the price, the latest price that was stored at that time in the store. So yeah, really, really cool stuff, right? So we're going to get last. Remember, we pulled the key price by symbol, which is going to be denoted in ETH and USD. So if we wanted if there was another pair that's out there, let's say, I don't know, something denoted in ETH rather than USD, you would replace those values here. So what we're doing here is that the get last will return an option of the value in the store, because it's possible that there's no value in the store for that. So we're going to do a map or on that. So if there's no value in the store, we're going to return a big decimal of 0 because we don't have a price. If there is a price in the store, we're going to return the price. All right, so now this is going to be Now, the thing I was talking about before that I'm going to kind of rip from here. So we'll log this out so that we could see the price being emitted. Here, so we're gonna emit the admit in the console log the actual price that we pulled from the store, right? And then we're gonna loop through the events properly this time. So I'll step through this all with you. It's just easier for me to do this way. That way I don't miss anything. So rather than the for loop, we'll just do like an iterable on the, so want contract submitted USD. So we're going to create a vector of contracts of submitted USD. We take the events. We want submitted. Should have, where is it? Lido submitted. That's the vector we want to loop over. So we'll use that into iterable. It's up a little for my viewing. And we're going to do convert the amount. So the amount of Ether is stored as a string. We got to convert that to a big int, it looks like here. So that's what we did. We did big int from the string, the original amount, original.amount, unwrap. If there is no big int, we're going to do from 0, and we're going to do 2 decimals. So the big int crate in the Substreams libraries has this 2 decimal function. Obviously, it's going to allow you to round the decimals. We know it's 18, and we're gonna output that. And then instead of this user deposit, we're going to do contracts. Submitted USD, and we're going to get rid of these. And down here we have the ETH price multiplied by the converted amount, because we convert it with the dollar value, and we're going to just write that back out to string. And then we have the OK user deposits here. So the clone is in it. It essentially makes a copy of that, like in memory. If we were to access it directly, Rust is like very strict on like reusing variables in a way. So clone will just make like a copy of it in memory for you to use. So that's the best way I kind of understand it. So we have the US submitted, collect, and then this is, you know what? I'm gonna have to make another proto. Sorry, guys.
No problem. You're doing great.
Thanks. All right. So we created this submitted, but we need essentially an array of submitteds to return back. So we'll do, yeah, we could just do user deposits. It's fine. We'll call it user deposits, which has repeated submitteds. Regenerate this. Yeah, me too. Me too. Protogen. All right, so now we should have that in our. Another thing too is that when you import it, it will create all the protos of the imported store, so you could see them here now too. This wasn't here originally. So here's all the proto structs that were created. So if we go on this contracts one, we have the user deposits, which is of has a value of deposits, and an array vector of the submitted USD values. So we'll take this. So we want to come back here, and Look at this deposit and price thing. So yeah, we're going to do the user deposits back actually, instead of just a single submitted. Submitted, okay, user deposits, contracts, user deposits. All right, let's see. Let's see if we get any errors when we, sure we will. All right, so we got to import the begins from the substreams. This, oh, Lido events. That's why that wasn't popping up. Let's fix that. And chain link prices. Oh, chain link price. That would be why. And let's import begin. So I should be able to just do this. Yes, no, yes. Yeah, right here. Same thing. What are you complaining about? Okay. Now let's go back down here. See what. Okay. All right, we're looking real good now. We're looking real good. We could see that this is now returning the type of the big decimal that we get from the store. We do the loop over on the vector. I can't help you with that. Hopefully somebody else can, Nico. The only error we have right now is the multiplication. All right, so you have to import those from the standard Rust packages, which I'll take right here. Ended operations. Listen, it's been like Rust has a high learning curve. So these things aren't like baked into my brain. But once you actually start using this, it becomes so fun. It really gets me excited just like building out these substreams. So we'll do this. All right, I think we're good here now. We got no errors. So let's fire this thing off. Let me make sure my substream manifest is proper here. Let's see what I did in my substreams. So deposit and price and this store chain link prices. Great. And that should be it. All right. So we'll save this up. Now, let's do a make builds. So we're going to build up the project right now. That way we could show the emissions in the Substream GUI. Build fine. Good sign. Always a good sign. Right, James? Okay, so we're going to run it now, right? We're going to run it, but we're going to run our new map USD value. So we'll do substreams GUI, point to the manifest, and we're going to run this map USD value now. Fingers crossed. Fingers crossed. All right. Great. So now, we could see here, log big decimals is 0. So we have no events that admitted for the submitted in this block. Well, we have no big decimals. So come here. Oh, there's no message descriptor. What is that? So we're not going to be able to see them coming out. Let me go back. I think that has to do with the protobuf definition. I'll go fix that real quick, but let's navigate the blocks. Okay, so remember I told you earlier, when you import the store, it's important to find out where that pricing like left off. For the sake of the demo, I just want to start it as soon as I could, just so I could show you guys. But again, we really probably should run it from the beginning of time of the Chainlink price store. But that would take a lot of time in the demo. So you could see where we're logging here. Big decimal is 0 because we didn't get anything from the store in that block. Now, if we go to the next block, big decimal 0, nothing. Big decimal 0, nothing. 0, nothing. So we still at like this block range, we still have no USD price admitted from the Chainlink price store. Now, finally, we have a big decimal here, right? $653.50. That's the USD price of ETH. We put that in the module to log to the output. This really should be showing the full structure of the submitteds. I have to look into that real quick. I think it's like missing a display or something. I'm not too sure why that would be the case, but you can see here we have $647, 650, 647, 650, 647. So these are all, it's logging out every single price that we got from the store. Now, again, in this demo, I showed you a lot of like just substream development besides the import. But if you take into the import process as a whole, all we did was add up here. We added, actually, you know what? Maybe that's why it's not doing it. Let me stop this real quick. User deposits. I'm outputting the wrong type. So this user deposits should now. Let me see if this works now. There we go. All right. So now we have the actual deposits that are coming out of our module. With that being said, we have 0 here, right? We have 0 on this one because we're not getting a price from the store at that time for the reason I just explained. Big decimal. Now let's find the one that is actually going to admit with price. I guess it didn't come up yet. Going slow. The fire hose is it's lagging on me here. So while it's syncing up, let's go to the YAML, which I'm on, right? The manifest. So to import a substream into your substream that you're building, all you have to do is add in the imports, link it to the SPKG, come into the network overrides if you want to override the start block, go to the new module you've built, and put inputs store. That's it. That's all it really takes. You don't have to really do anything else besides that. When you want to access it, sure, you come into your module, you add Chainlink prices with the type of store it is, and now it's available to you. It's like really like 5 lines of code, you know? So that's really what excites me the most with dealing with substreams. I really try and stress that mindset. Like Derek posed the question earlier of like, hey, could you overwrite contracts with this? Like when you build out substreams, you really have to think of the modular approach to this and the composability of it while you're building it, because the community itself should be helping each other rather than I'm building one price oracle, this next guy is building the next one, this other dev is building something else. So you really want to see that in fruition. So let's go here to see the ones with the actual price. Okay, so you can see here, this person deposited a small amount of Ether for a value of $6.53. Same thing here, same thing here, same thing here. Yeah, if I could go into that. I'm not fully prepared to do such, but we definitely could. We definitely should do one on that. Just like deployment of yeah, it's really simple, but we should do one on deployment to Substream powered subgraph, like how this actually ends up on a subgraph. I could show you. So what I could do just in the short term, again, the init command shows you the so you have it. You have a schema file here. I'll go over as best as I can. You have a schema GraphQL, right, which is generated from that init, and this is every single entity that is emitted for this substream in configuration for the subgraph. Okay. Now you have to have a module that will admit something that the graph could understand, right? And what the Streaming Fast team did for that is they built this. If we go into the base code here, they've built this entity changes table. Okay. So the entity changes, they have database changes, which is for your database updates and deletions. And then they have entity changes for actually just syncing with the graph. So if we go into the graph out here, they have this function graph Lido out, which if we look at this, what they're going to do here is they take the events and they take this table structure. So think of it as a table that you're writing to, right? And what they do is it's a mutable table, so it could change over time. And they're going to loop over the events that we've previously mapped out directly from the first module. They're going to say all of the events of Lido approved. I want to do this. I want to go to the table. I want to create a new row. So in this row, the table name is the entity name that would be saved in the subgraph. And so this Lido approval is going to be the entity name. And what we're going to do here is we're going to set each value of the entity. So this entity is just a string, and here's the value. Here's the event, here's the value. Same thing over and over and over again, right? And what this does is then when we run this, sorry if you hear my my daughter screaming in the background. She's excited watching it that work. So we'll go to Substream. We'll do GUI here again. And rather than do the new module, we're going to do the graph out module that was created. That way we could see what's actually coming out of this. Now you could see here now, this is the communication of the substream to the subgraph itself. So we have this entity changes array that's emitted. It has the entity name, has the ID, right? Most important thing when you're building a subgraph, the IDs. The ordinal, so it knows how many times that entity changed in the given table. So you could say, oh, this entity was created and then it was updated. It would have that ordinal of succession of those changes. The operation is create, and then here's all the fields of that entity. So we have the index. This is just ripped directly from the substream. Now, as far as actually deploying this to a subgraph, all you have to do, at least based on now, once you have that graph out, you have to just configure your subgraph, right? So we have to have a SPKG file, right? So after this is done, you would do like a substreams pack and went into the manifest. This file right? No, I didn't. That's why. Substreams. So what this does is it packs up our substream we just built, and it'll create a single file for similar to the way we imported the Chainlink prices, right? We're importing SPKG file, so the pack just packs it into the SPKG file for your use. And then in your subgraph manifest, we're going to point it to this. Let's see if it's the same. Demo, Lido, version 1.0.1 SPKJ. So now we have the file locally. That's what we're going to actually publish to the graph. And the next step really is to just create your subgraph on the hosted service, or, you know, obviously we want to get to a decentralized area, but you would just do the same thing you do at this point. Once you have that SPKG and the module name of graph out, which is emitting the graph out entities, you would just do graph build, then graph deploy. That's it. And it would just go up and start syncing. So we could probably do a more detailed version of that, like updating a single value in an entity. We definitely could we definitely can make it a nice little session here. But Haka, I hope that's a good way.
Definitely. Also, shameless plug, Substream triggers and subgraph mappings. I would love to see you all tinkering with this kind of stuff too. But this was super helpful for me, just as like us in the technical dev side lately, just seeing like users do this. So thank you. Really appreciate these kind of demos. I'll try to come more.
Awesome. Oh, that's cool. So, what is this you actually linked here?
Newest graph node release, and we've kind of enhanced the Substream's powered subgraph experience. So now you can feed Substream's triggers directly into subgraph mappings, and I don't think you need the graph out module anymore. It's like a different workflow. So I'd love to see you all.
Oh, so you made me explain that whole thing. Now it's not even applicable anymore.
I mean, it's still applicable, but it's like a different. There's like a fork now where people can kind of choose. So I think some people will still do graph out, but there's another option.
This is super, super cool. Yeah, this is awesome. I can't wait, because a lot of the struggles I've noticed, like when going from like a substream to a subgraph, is like you're just kind of limited on like the communication front between the two. On like you know, you take a subgraph that's already built and you could access the subgraph store directly and just say like, hey, pull in the latest one. Boom, I just want to write this value. And you have to really think when you're building a substream on like how to morph the substream into that line of thinking, because you don't have access to the subgraph store. So any improvement in that area, I really can't wait to dive into this. This is great. I'm going to definitely read this over. Thanks for throwing that in there. But I don't really have anything else, guys. So go ahead. But what were you saying?
Thanks, sweet. Yeah, thanks. Don't hesitate to reach out. I'd love to, if it's annoying or if it still sucks. Yeah.
Yeah.
Let us know.
Definitely. I'm definitely gonna look into it. Definitely. I spent a lot of my time on the substream side of things, so anything that's gonna make that better, I'll definitely let you know. Cool. So, Mike, I think I'm good on my end. If anybody else has any questions or anything they want to throw in and talk about, I don't know how much time we got left.
We went over a couple minutes. This is great. It was perfect. You did very well.
You got the right guy.
I did.
New Yorkers who don't want to shut up.
You'll take the winner. All right. So that's all that we have for today. So I'm going to post links in the chat for those viewing for the BuildersDAO regarding the BuildersDAO website, Discord server for any developers who want to participate in the BuildersDAO. Additionally, I'll put a Twitter link. BuildersDAO has our own Twitter, so please follow us on Twitter. You can on there. We typically post any new development works that we create, good works by the builders, etc. If you're going to be viewing this on YouTube, then please subscribe. If I don't ask you to subscribe, then did I even post it on YouTube? With that, again, I want to thank Thomas for your presentation, and you did so good. We'll stick around a bit more after the recording just in case there's any further questions or comments. Otherwise, we will see you guys all next week.
Jurgen asked, how big is demand for Rust devs in the DAO? There's always a need. You know, like we majority, I would say majority of our work is subgraph related, but
for now.
yeah. I mean, but that doesn't mean that we haven't done projects on Substreams. So, when I do go out, like I said, I do the product procurement. I do always bring up Substreams as an option to them, just for its flexibility and use. So it's really dependent on what type of bounties we have up, and we have a nice array of different things people could do. So, thank you, Derek.
I was going to mention that as well. Well, that's totally fine.
Yeah, I just had the release notes up, just showing them off. Because I can't wait to read this now. So, but all right, I guess we're good, right? Nobody else? Any other questions?
I think that's it. Everyone, have a great day, and we will see you next week.
All right, awesome.
Thanks Thomas.
Got it.